So we're back in the attic now talking about common airflow problems. Things that contribute to poor airflow could be high static pressure, not getting enough return air, causing your fan to work harder and suck through. You know, imagine trying to run a marathon only sucking through a coffee straw. You're not going to get much air, and therefore you're not going to get much performance either. So you want to look at the return sizing. You want to make sure that there are no major kinks in any ducts that are on the supply side or the return side that's going to inhibit the air from getting through. Another common issue that can affect airflow is duct leakage. So when I come up into the attic, I want to look and make sure that all of the seams here are properly masticed wherever there's tape. These starting collars are going to be masticed on the inside of this mastic. This mastic here is actually just a vapor barrier. Inside here, you're going to want your air barrier properly sealed as well. On the return side and the supply side, obviously this is the return side, but it matters even more so from an airflow perspective on the supply side. So another place where duct leakage can happen is right here at the seam where the supply bucket meets the sheetrock. And if this isn't properly fastened, sometimes these things can get knocked loose, and then you're blowing air straight into your attic and it's not going into your living space. This can be all sorts of different problems, from air quality issues to just not getting enough airflow in the house, to then also allowing a hole from your attic to go into your house, where obviously the hot humid air is then going to get in and mix with your nice conditioned air. As you can see here on this one is thoroughly covered with mastic on all of the seams up top, and then it's actually caulked on the bottom where the supply bucket meets the sheetrock on the inside of the duct, not on this side. So this is a thoroughly sealed bucket. So now let's talk about some other types of airflow issues you might run into. To do that, we'll need to talk about different types of ductwork, and above me here is some nice metal ductwork. Metal ductwork is one of the best types of ductwork because there's very, very little resistance for the airflow that's going through to get caught up on. It's also really, really rigid. When done right, you can really stop the duct leakage, and it's going to be sturdy enough to withstand the next 50 years of people crawling around in your attic and things like that. Some other ductwork includes flex duct, which sort of looks like an accordion type of thing. It's silver on the outside. Let's see what we got. No, we don't have any here. That's okay. Unfortunately. Yeah, this is sort of it, but if I'm going to show it, I'd like to show what it actually is. So another type is flex duct, and it's an accordion-shaped spiral tubing with insulation on the outside, and that is very cost-effective. However, it takes a lot to manually seal all of the seams, and even then you're not sure if you got it all, and it sometimes gets brittle and tears, which can create duct leakage and cause some issues down the road. As well as with rats and rodents and things like that chewing into it over time. It's just not quite as durable as the metal is going to be. The third main type of ductwork is ductboard, and typically ductboard is used in conjunction with your flex duct, and that sort of looks like this. This is going to be the outside, and then this is the inside insulation. So ductboard here, you can see it's got this reflective liner here. This is its air liner. Inside here is the insulation. And if you don't have an air barrier on the inside, you really need to make sure that this air liner gets sealed, because any sort of penetration or cut in this is going to cause lots of duct leakage. And you're not even really going to notice that there's leakage, because you see this backing and it looks sealed, but this is very, very porous insulation, and you also then lose your R value since you've got air moving through your duct, through to the attic. So now we'll take a look at a few other examples of flex duct and ductboard and metal ducting. Alright, so we can now talk a little more about different types of ductwork. This is called metal spiral duct. This works really good when it's in conditioned space, because as you'll see, there's no insulation on this duct, so it has to be in conditioned space, otherwise it's going to condense and there's going to be all sorts of air quality issues down the road. Also, there's lots of duct leakage that's associated with this. This is not airtight. But it's okay, because if this duct is in conditioned space, then whatever air leaks out goes into the conditioned space, and it's totally fine. Another example is this here. This is typically what flex duct looks like. The outside is sort of a little bit of a radiant barrier, and it holds the insulation in place and protects the insulation. The inside, this in here, is the air liner. This is the important thing to get sealed from an air leakage perspective. Both layers need to be sealed, but this inside one is really important because if it's not sealed, then the air can just go straight through this insulation, and now you're ruining your R value with duct leakage inside your ducts. So you can see with flex duct, it's very flexible. And you can see it's got these ridges in it, and obviously, you know, you want to stretch this as tight as possible because you want the least amount of friction to be created inside and like basically a way for the air to slow down. You want to be able to have a smooth path for that air to go through. So this needs to be stretched as tight as possible, and a lot of times in new construction today it's really difficult, one, to stretch it as tight as possible, and two, to stretch it in a straight line wherever you're going. Sometimes you've got trusses or other attic supports and things that you're going to have to snake around, and so you want to keep those sort of cuts and lines to a minimum. You want to have proper duct design so that you don't have to make a bunch of bends and turns in this, because it's going to ultimately ruin the efficiency of your duct design and system in general. So anyway, this should be stretched apart a lot, otherwise you're going to decrease the amount of air that ultimately gets to the end of the grill. This air liner, as you can see here, sort of comes apart. It gets kind of brittle over time, and animals love to chew through the insulation and get inside this. So from that perspective, it's not quite the most durable product, but you're really going to save money on your install, and that's the reason why people would go with this over metal ductwork. One other thing to mention, here is a supply bucket, and typically the flex duct or even metal pipe will connect to the back side of this. And you know, we were talking about duct leakage earlier, and each one of these corners here leaks a little bit of air. And you know, you have 20 of these in your house, it can really add up the amount of air leakage that comes from just the back side of this bucket. Not to mention the front sides here have little slits, and this thing leaks air all over the place, and the HVAC contractor needs to know that those things can be sealed up to really improve the efficiency. So now we're going to be talking a little bit about how supply side duct leakage affects airflow and ultimately comfort in your house. So when you've got supply side duct leakage, obviously that's duct leakage that's leaking, going to a place where you don't want it. It's going to your attic, it's going maybe to a cold, damp surface where mold can be created. You know, you really want to limit the amount of duct leakage you have in general. But also from an airflow perspective, if you have a lot of duct leakage, that air is not making it where it needs to keep everybody comfortable and to have your system run efficiently. The next thing that we can talk about is return side duct leakage, and this often gets overlooked mainly because, you know, when you're in the attic and it's supply side duct leakage, you can feel that cold air blowing on you in the attic, and you know that that's not good. But on return side, you're never really going to be able to feel the air sucking in, and even still, it's going to be lukewarm air that's going in, not going to be cold air that's coming out at you. So you're not really going to feel the effects of return side leakage. But the problems with it, not just from an air quality perspective, but also from an efficiency and airflow perspective, is that air that's getting drawn in is going to be a lot warmer than the air that's already conditioned. So your coil in your house is designed to decrease the temperature of the air by about 20 degrees. It's about 55 degrees. Your house is typically about 75 degrees, and it's going to then cool the air by about 20 degrees, give you 55 degree air coming out of your vents to then cool the house and start the process all over again. When you have return side duct leakage, you're going to be introducing 90 degree air, maybe it's air from your attic, 100 degree air that also hasn't been dehumidified yet, which means that you're introducing hot, humid air into this cooler air environment. Now that those airs start mixing together, you now have a warmer temperature on your supply side than you ideally would, which means it's going to take a lot more circulation of that warmer air in order for you to be comfortable in that room.